I'll put a link down to this motor. I bought it direct from that website as opposed to somewhere else, and it's pretty, well, it's quite hefty. It's not overly weighted, but it's quite heavy, and it's got this gearbox on. Yeah, oh, with cogwheels in there, and it's got this sprocket on here. It's like a chain type sprocket. It's got a bracket on the bottom. This takes M6. These are threaded, so you can screw bolts into there direct. I would say put a lock and nut on or something on, just make sure it won't come loose. Couple of threaded holes in here, so I've got a couple of, well, about three holes here for also extra if you want to bolt something on. Right, I've got this wind up to a 12 volt PSU power supply unit, just a standard power supply unit. I'm going to turn it now. Watch this when it first turns on, it'll jump a bit. You see, it goes quite quick, not too noisy, very smooth. I don't have the strobe now, the camera might take that out. But if you look at the label, the gear ratio is suggesting, you might as well say 10 to 1. So for every 10 the motor turns, this turns once. But it's going at pretty fair speed there. I think it's 300 revs a minute. This is a e-bike motor, electric bike motor, that's what it's claimed to be anyway. Let me turn it off before I move it, get my hand caught in it. I'll go and get a bit of chain actually. It is a brushed motor, so there are carbon brushes in this one. I bought one of those because it was a bit cheaper than buying a non-brushed version, which you can get. So if you couldn't read that, it was 24 volt. I'm using this off 12 volt PSU, by the way. It's a 12 volt PSU I'm using this off. It says 3000 RPM. I presume that's a motor inside, so if we do a 10 to 1, that's going at 300, well, near enough 300 revs a minute. It's 9.7 to 1 and 350 watts. Okay, now this is for my shredder, and this is the sort of thing one of the connections I've got to go to the shredder. So that fits on there, and then this fits on the shredder side. This is a bit long actually, a bit sort of deeper. If I do another one, it's a bit of a thing getting it on, but there we are. It goes on there nicely, like that. And that goes on a big nut head, bolt head, sorry. This is a shredder thing. Look at my other videos, so it's got a cutting disc there. Okay, and it's got this big M22, I think it is, bolt in there, and that nut shape, this side, does fit on there. I've done a test of that. I'll just turn it on and off again to show you while that's on actually. So it's a bit of noise, but it's not very noisy really, especially if I take it off the wood. So you're getting a bit of reverberation there. But very smooth. I can't really feel any vibration at all. Only very, very slight. I want to, so can you hear that? I want you to listen to it stop as well. It feels a little bit like it's going a little bit rough there when it goes to slow down and stop. I don't know if that's the gears inside or what. It's got quite a bit of kick to it when it switches on, like the torque going backwards. Don't get with the like friction of the gears. That's going to give a bit more of a kick. Yep. So if it's powerful to power a bike, it should be powerful enough to power this shredder. Now I've had some sort of success. Let me turn it off. By the way, most of the noise, if you hear noise there, is the actual PSU fan and that. I've had some success with this using a windscreen wiper motor, some success, but kept on jamming, and I had an awful lot of problems with this connection sort of slipping on this nut, well, inside this end on the wiper motor. But I'm hoping that this will spread all those teeth in a way. I'm going to spread any torque, any pushing power across each of the teeth, and that should be okay. I'll just get a bike chain to try this. I do have a bit of bike chain. Now there are different sizes of chain. I'm not sure of the size of this one, to be honest with you. I think I've read that was 1/2 inch or something somewhere. So here's a piece of very old bike chain. Got in a loop here. I'm not sure of the size of this. I just want to see if this one even anywhere near fits. I don't intend to use a sprocket. I keep thinking of sockets. Yep, that's gonna not fit on that torque. Yep. So yeah, I've got this unplugged, by the way. There's no way I'm, not going to have an accident with this on. There's a ton of torque in this, like turning force. But that's just a pretty standard bike chain. It's very stiff, this bike chain, because it's been laid out for absolutely ages. So put some sizes on here, by the way, on this video. Let's see, I think we've measured these in inches actually. So from point to point, like, yeah, about half an inch there. Don't know about the width of this. If you do the total width, not sure if these are in eighths. I think they are, so that would be 3/8 if it is. Metric, which we should all be in England anyway. Everything's upside down in this camera, so you'll have to forgive me. That's about 14 millimeters. And this should be about 12.5. Yeah, I'm sure you can see that from point to point. Okay, so that's just a guide there. I don't plan to use a chain, but if I do, one good thing about this is you could like go to a bigger sprocket, and that will give you more gearing and turn a bit slower. This turns a bit fast for mine. I'll be honest with you, I'm scared stiff about using this because I think it's got a lot more torque and it's going a lot faster. I'll just show you that a bolt does screw into the base. I've already tried fitting one in here. They're quite a snug fit, probably because of the enamel. This is like enameled. See, that screws in there, into there, and I'm having to use a spanner because it's going quite tight. But I would say this side I'm going to use a washer, and that side I'm probably going to use like anti-vibration locking nut, nylon nut. Anyway, let's get on with it. So that's just 12 volts, positive and negative. So if I swap the wires over, it's going to go the other direction. So that's the correct polarity. Let's switch it on again. I'll have to go and turn the mains on to see which way it turns. I'm holding this because the jump it does when it turns on. So it's quite a bit. So that's turning clockwise. It might look like it's going anti-clockwise in the camera because of the strobing of the camera, but that is going clockwise when we're looking at it from this side. Watch when it slows down. Yep. And that's with positive going to positive, negative going to negative. 12 volts here. I do have a 24 volt power supply unit if I need to use it. But let's try the 12 first. Right, I'm going to show you it on 12 volts and 24 volts. I do have two power supplies here. I have a 12 volt below here in this plastic box printed out, and this is a 24 volt on top. Okay, I'm not sure of the amperage of these. This is 480 watts, that one says. This will be about the same, the one below. I'm going to hold it because, as I say, when it first starts on, it gives a bit of a kick. Now this is on the 12 volts first. And that is turning clockwise as you're looking at it. It might look like it's turning, well, it certainly does look like it's turning anti-clockwise in the display I've got here on my camera, but it is turning clockwise. That's 12 volts. I daren't grab it because it will have a ton of torque. This quite a beefy motor, as you see. This is nearly all the motor here, permanent magnet I believe. A brushed motor with gears in here that give it more torque, it turns slower. So this is saying 3000, I think it is. Yeah, 3000 RPM, and it's 9.7 to 1, that's the ratio, so it's as good as 10 to 1, so that'll be going about 300 RPM there, we reckon. Right, let's get on 24 volts. I'll turn off the camera while I do that. I'll just leave it going a little bit there. It's moving a bit. It's quite quiet. It's making more noise because it's on this bit of wood there. This is just a test bracket I'm making for my shredder, because I'm going to mount this on my do-it-yourself shredder. It's just testing the fits, print out a part like that to get it, make sure the sizes are correct. Trying to show you around it. Okay, let's get that on the 24 volt now. Just walking a bit here because of slight vibration. And some of the noise there, certainly, well, probably quite a bit of the noise is coming from the PSU power supply, which has a fan in, okay. This top one also has a fan in. I think there's a quiet fan I fitted in there. But we'll get this 24 volt wired up just now. Okay, it's wired up to 24 volts. Now I've got to hold this while I plug it in, because on this box here, this plastic one, which I have the 12 volt power supply system in, it has a switch on, turn it on and off, but this one hasn't. On the 24, it's just direct to the mains. Let me try turn it round, because I'm going to be leaning over here. I don't want to be leaning against those contacts, even though there's a plastic plate on them. Right, try and get that in the camera while I just let me get, can I get a better grip of this? I'll hold it on there. So I'm pressing it on something because I think this is going to kick quite a bit on 24 volts. Yep, bit of a kick. Hope, to me it seems to be going a lot faster there. a lot faster. So that's probably 300. The other one we have to assume was 150. Again, it's turning, it's hard for me to tell, it's going so fast. Those like teeth of the cogwheel there, blade on the camera, it look different. It look like it's going clockwise as we look at it. And you can hear this quite a bit more noise there. So that's on 24 volts. A little bit of fan noise coming from the PSU, but not too loud. I mean, if you had that on a bike outside in the traffic, whatever, I don't think you'd hear it very much. And probably this is, well, going full pelt, I reckon. You know, there's no like turning down the speed of this, well, what I'm using here. Okay. Let's stop on 24 volts for a bit so you can hear it. In real life I can't see those teeth spinning around on the display can, and they'll look like they're flickering. Right, let's get that unplugged. Be careful here. When it's on the shredder, at least initially, I'm going to power it off 12 volts, so try that first. Okay, just wanted to get a comparison of the speed and the noise there. If I can, I'll put two videos side by side. Right, that make sure I have unplugged that, yes. Safety first. So I'm printing out the part now for the like bracket thing here. This fell down actually when I was moving about and it broke the plastic off here, but this is just a test piece, test fitting. So it does have these screw threads in the base plate here that you screw 6mm bolts in there. I would probably recommend like a spring washer or tooth washer on the other side here at least, if not even another nut on there, just to make sure it stops on. It does have these other mounting holes here if you need to use them. 3. Those look like M6. Right, I think I'm repeating myself. Right, next time you see it, it'll probably be hopefully on the shredder. So this, I'll just show you this. This is the like coupling thing I've printed out. So that's going to go on these teeth here. Bit of a push, but they do push on there. And then that's going to fit on the big bolt head. 22mm bolt head for the shredder I'm going to be using this on. So I'll just let you look at the label again. I'll put the details below and a link. Right, I've connected this e-bike motor up to the shredder. using this coupling thing here that goes on to the sprocket wheel that's on the other side, and there's a no big bolt head on that side and like a sprocket wheel on here. This does go through gears. Now I'm going to be procrastinating a bit here, I think, because I'm dreading putting this on, because this has an awful lot of torque, probably, you know, I imagine quite a bit more than the wiper motor I was trying, to be honest with you. Just let you see that first. So it might rip this bit to bits, I don't know. I think it's only 50% infill, but I'm hoping that the teeth of the socket on here will spread the load out. Right, that's all bolted in on this bracket I printed out. I had to drill an extra hole in here because my wood is over the edge, so to speak, here. Cross members there to give it a bit more strength. I think that should be damn strong enough, I hope. I'm going to switch it on just now. First time I'm switching this on while it's been like this. Okay, so I'm going to turn the camera off while I put it on the tripod. Right, again I put on this bowl here to catch any shredded plastic if it works at all. This is off 12 volts. 12 volts, this is a 24 volt motor. Right, I'm going to get ready to turn it off quick. I've got my PSU here in this box. So you might hear some, quite a bit of noise, might be the fan noise actually of the PSU. 5, 4, 3, 2, 1, getting ready to turn it off. The only thing there is it's turning the opposite way to what I want. I don't know if you can tell that because of the strobing. This has ridges on, so that's got the strobe, but it is turning anti-clockwise when we're looking at it here. So I'm going to just swap the wires over and try again, but that's going pretty smooth. I'm quite pleased with that. A bit of a rock here. This is a very quiet motor, this. Believe it or not, we've got like amplification here because of all this thing. Yep, so I'm going to swap the wires over, then I'll come back and we'll see what's what. Right, all I've done is swap the wires over, so now I've got like positive here going to the negative wire on the motor, and negative going to the positive wire going through this terminal block. Right, that's all I've done. It's now I will say that I tried turning this by hand with the coupling plastic thing on, and I found it a little bit harder to turn one way than the other, so I don't know what's going on there. I'm just turning it on and off to make sure it is going the correct way. Yep, it is. Right. I'm just trying to find, I'm going to try this bit here. This has been chewed before by my other attempts using a drill electric battery sort of motor and a windscreen wiper motor. Right, let's go for it. Watching my hands here. So we can see this does have some infill on it. Just a second, this is moving over a bit. Oh. move a bit closer so we can see what's going on. We can. Let me measure this actually, let's see how long it is. I'll show you the ball just now. So to the longest part there, as it is, it's about 120 millimeters. That's just to show you that it is putting it down. It does feel to me, I think that's bumping up there, and the blades are going underneath that. That's why that's not cutting so much. Try and cut some of that off. Well, you can see that's got shorter. That's about 70 millimeters to the longest part there. Well, longest bit of this, what's left. Okay, I think I'll stop it there. Let's feel that. Not warm at all. Quite cool. Let's have a look underneath as it is now. Let's move back a bit so you can see what's what. Yeah. So that's a lot more success than my other attempts. Still shredding up, you know, like quite granular. And that's in, well, that length of time, 10 minutes or so maybe. I mean, this is all prototyping. Now with this extra power, I imagine I could have more blades on here. Now quite often it's with shredders, it's to have counter rotating blades sort of thing and trap it in, but I've got this like block on here to bang, almost hold the plastic against, and then, well, it cuts better like that than having knocked the plastic on, so to speak. Sorry, I'm not talking a bit gibberish here to a certain extent, but it's better with that on because the blades cut against it like something solid. But basically with this extra power here, with this eBike motor, I'll put some details here, is that could have more blades on. If I do that, then I'll probably double the bearings up on each side. There's big bearings on a, I think it's 22mm bolt that goes through here. Look at my other videos of this shredding and see what's what. But that's have it. That is a big success. Now let's try some other. I'll get some. Let's have a look. See what I've got that we can shred up maybe. This is an attempt of making. It's for a Black & Decker drill to go in here. This is just the first prototype. So you can see the thickness of that. This is very light. So I imagine the infill is weak in a way. I would say 25% there. maybe. Let's try this one. Oh, I'll cut this a little bit more just to show you. So it's getting a bit near my fingers here. Have to watch your fingers. Let me try this edge because that's a bit thicker there, if I can get it in. Look at that in a short time. It's got that big groove in there. That's using this cutting disc here. That's for cutting metal. That's harder, well, it's harder to get it positioned in there to do this. I can't turn it, I can't fit it in this way around at the moment, not with this design. Oops. It's not, have to be careful. So this might look like it's going, I don't know which way around in the camera, it looks like it's going very slow this way. This part here almost looks like it's going anti-clockwise, but it is all going clockwise. About 300 revs a minute here. That's getting a bit short for me to hold there. They ain't going much shorter than that. I'll just get the measurement of that to the longest part, what's left, which is about there, about 50 millimeters there. So let's try this. I think the infill on here is very small. Yep, we can see that the infill there is, I thought it felt light. What I do is print out like a smaller infill one when I'm doing prototyping. It saves plastic, saves time. Oh, I'm just checking something there. The problem here is actually getting in. The way this is actually getting into here with something like this big. Let me just try, imagine this was just dropped in here. I mean, there's so much light weight on this that actually, I'm thinking there might benefit from having something with bigger teeth than this cutting disc I've got here. It's almost to me like the blades aren't even touching it. Now what I think it is there is because this edge is lower and that's almost pressing on the part behind to a large extent of the blades. Let's turn it round. I'm going to give this a bit longer to see if this is getting warm, the motor here just now. I'm feeling the motor and we'll see if it's even getting anywhere near warm. Can I get in down like that if I move this over a bit? Like this, can I? As I say, this is all prototyping, so don't criticise. But you see the edge is there that was cutting very well. This is a bit thick, I think, for this, the way it's designed. It's not the power, it's just the way all this is designed. It's a bit thick to handle. Another very lightweight item, maybe not so thick. Just a second, I've got to pause a bit because I'm leaning over here and it's hurt my back. I just feel if there's any warmth. No, if there is any warmth, it's very, very slight indeed. I'm going to have a rest here because it's taking my back the way I'm stood. I'll just show you the ball first though. Now, so we chopped a little bit more, I think. And I aren't faking this. Oops, some of it's coming out. Probably ideal to go into a homemade like pellet to filament thing, I reckon. But that's the best success I've had. Now I've got, well, a reasonably decent motor and I think a more decent coupling there. What I'm going to try and do is get the camera actually pointing under here, okay, if I can, so we can see any bits coming down. Okay, pointing at the back of the motor at the moment. Let's go down. We might see some bits coming down here when I turn it on and start trying to cut. Let's go for it. The difficult part now is actually getting in here. So you've got, well, a reasonable sized part there, but actually getting in here and getting it held against the blade where it's going to cut. That seems to be the hard part now, with the design as it is now. I wonder if I took this block off, whether it would be better now. I'll have a think about that. I don't know if you've seen any bits drop down there. I was finding it very hard to cut. I don't think I've really got any more plastic there. But this looks bigger than what is to a certain extent because there's a lot of air gaps between it, but there's a fair amount there in that time. So obviously getting that e-bike motor here, I'll put some details below, well, a link to below, is, well, a lot better than the other methods I've been trying, and enough power there to, as you've seen, to cut that earlier bit I was cutting. I reckon that's 4mm there, and you've seen how it ate that away. Right, so I class that as a success to that stage. I've got to think about removing that block maybe and seeing how it goes. Okay, I've took this block off. I printed it with that like groove in there for the blade to go around. I use this so that, let's look at that actually, just a little bit chewed there, so that when the blade, see the blade's pointing up there, that it'll sort of, you know, have a good thing to bang against almost type thing, rather than but we're going to try it like this without the block on. I'll find a piece, at least might be able to get in a bit easier. As you see, I've turned this so you can get a different angle of it. See, this is a, I think it's 22mm, couple of nuts there, half nuts with a Nord washer, I think it's known as, type thing. Likewise inside there's Nord washer and half nuts and such like. You might just make out the big bear in there. And zoom in on that. Okay, so if I do make it wider, and you know it's going to take more like energy out of the system, then I might put double bearings in each side and make this like a double layer of this to give it a lot more strength. Anyway, procrastinating again I think. So you see, let's show you that before I start showing it, so you see the level of chew. This is very lightweight, very thin. This didn't print at all well. Look at that surface on there. But anyway, just a test piece. Yeah, let's turn it on and go for it. See, that's probably chewed up most that corner there. I would say I'm having to press quite firmly here. You know, if I just put that on and rely on gravity, let's just hold that there. It's just bouncing, as you see, it's just bouncing there. Especially a lightweight thing like this. Just a second, because this board's moving over a bit here. Have to watch this. As I say, this is just prototyping, just to see what's what. So this blade at the moment is turning anti-clockwise to the direction we're looking in. The strobing of the camera and the lights and everything else might make it look. No, it's almost ripping that off there. One problem here, I'm having to press quite firmly to hold it onto the blades. Well, I think it's better like that. Well, in a way it's better because I can get bigger pieces in. There's a tendency for the blade to push parts over to that side as it's trying to cut through them, it's taking away. Zoom in and keep this in focus. I think that's like the layers, I mean the like surface shells, and some slices call it. Let's try looking underneath here again. Okay, that's showing you sort of inside the ball. See if you see any bits falling down there. This board over, it's sliding off again. Knock the ball. Just a second, let me try and get this back into focus. going to leave it at that. I'll just show you this. Let me move back a bit. Here, this bit of, like, it's just a bit of shelving. I have these balls that drilled there. I think it's 12mm halfway through, just to almost countersink them into the wood there. Just a bit of shelving there. Show you the ball now first. So getting quite a bit in there. Don't forget we've been stopping a bit to most of that's quite granular, and you can see the state of this now. Very low infill. Look, I can feel that it didn't come out at all, this print. The setting's wrong. Look at the infill on there, well, 20% maybe. It's showing that up alright. So I think one of the main problems is now I'm having to press quite firmly to hold it on the blades. It's not like the blades are taking it in itself. That's one advantage if you have the counter rotating sort of things. The two counter blades are almost like teeth on the blades are bringing the part into itself. But you need a really powerful motor for that, and gearing and such like, unless you have two motors obviously. And that's something I'm going to have to think about. What I thought about here is, because it's got sprocket on, I keep going to say socket, but it's a sprocket, like a bike chain sprocket, is that you could actually put a chain on and have a bigger cog like on the other side, so you get even more gear and go a bit slower, get more torque. But also on that sprocket you could, wangle it maybe some more like another one of these, but going the opposite direction, like the blades are almost going that way to each other, going in and out. You know what a normal shredder looks like. Right, just okay, so that's a lot better than using my other motors I was using. I don't think there's anything else I can say. Let's feel that. No, cool. Just like normal room temperature I would say. Nope, let's feel the gearbox. Nothing. Just normal temperature there.